Hey guys, people had been asking yesterday for help with this particular problem, and then I also got a request for a video for this one. So I'm going to go ahead and do number 17 all the way through, and hopefully that'll help you with some of the more complicated ones. So looking at number 17, they're telling us the triangles are similar. They didn't even like rotate it or anything. So basically, the way it's matched up visually is the way it's going to match up, using the letters. So I don't think that was probably the issue. I think most people were able to figure out, PR, matches up with SU the same way that PQ matches up with ST, right? So PR matches up with SU, and PQ matches up with ST. So I think most people got to this point. X squared plus 20 over x squared plus 5 must equal 13 minus x over 7 minus x. And then from here, in all honesty, the geometry part's pretty much done. Now it's just a matter of the algebra part. So hopefully you're able to at least get that set up. Now let's actually solve it algebraically. So obviously, I'm going to go ahead and cross multiply. So x squared plus 5 times 13 minus x must equal x squared plus 20 times 7 minus x. So there's your setup from, after doing the cross multiplication. And this is where most people pretty much just said, okay, I'm not doing this. It's too much work, too many x's, too many, exponents. This is too hard. But it's actually not that bad. If you just took a little more time to simplify it, you'll see that the numbers aren't that bad. We're going to have to obviously do our distribution stuff where we have to multiply every piece, by every other piece. And so we've got 13 times x squared. You've got negative x times x squared, so that's negative x cubed. And here's another spot where you're like, oh boy, I must be doing something wrong. We don't usually get third powers, x to the third. But just trust it. You haven't done anything wrong. You've got your setup, you cross multiplied, you're distributing. Just go with it and see what happens. So, excuse me, x squared times 13, we did that. X squared times negative x, we did that. Now we got to deal with the 5. 5 times 13 is 65. 5 times negative x is negative 5x. And then we basically do the same kind of stuff on the other side. 7x squared minus x cubed plus 140 minus 20x. And let's just start simplifying. I don't know about you guys, but I see that negative x cubed on this side. I see the negative x cubed on that side. If I add x cubed to both sides, those are gone. So I don't even have to deal with that. Let's bring the 7x squared over. So that's going to be 6x squared. Let's bring the 20x over. That's going to be 15, so 15x. And then minus 140, that's going to be minus, 75? Right? So get all these pieces over to one side, set it equal to 0, and at this point it becomes a basic quadratic. Oh, maybe not basic, but it becomes a quadratic that we can deal with. The first thing I always like to do, if I see a factor that that goes into all three, I'll take that out first. So I'll take out a common factor. Looks like I can take out a 3. So that's 2x squared plus 5x minus 25. And if you got this far, it's not so bad because there's only so many ways to get 25. Right? The only numbers that multiply to 25 are either 25 and 1, which there's no way that's going to work, or 5 and 5. So when I break this down to factor it, I know for sure, I'm quite confident that they're both 5s. In fact, I'm even more confident to break this down because to get a negative 25, one's got to be positive and one's got to be negative. And now it's just a matter of, 2x times x, which one's which? Which one's going to be positive? Well, I know I need a positive 5x, so when I multiply my 2, I need to make sure my x's are more positive than they are negative. So this is going to be x plus 5 and 2x minus 5. Let's check it. 2x times x is 2x squared, plus 10x minus 5x is positive 5x, and negative 5 times positive 5 is negative 25. So either 2x minus 5 equals 0, or x plus 5 equals 0, which means x has to equal, what's that, 5 halves, or 2.5, or x equals negative 5. Do both answers make sense in the context of the problem? Let's check. What did we have here? 7 minus x. If x is negative, what did I say? If x is negative 5, well then that becomes still positive, right? I know maybe it's hard to see on the screen. This is 7 minus x. If x is negative 5, this becomes positive 12. That's fine. The negative gets squared here. That's fine, fine, and fine. So actually, even though x is negative, it still works. How about 2.5? That's still positive, 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 positive. And I could plug them in and actually get the values, but I think you guys could do that. Our two values are correct answers that both work are 2.5 and negative 5. All right, so again, just run through the main idea. Use the diagram and the similarity statement to get your proportion. Plug in the values. Let the algebra take over. And yeah, sometimes the algebra can get a little more involved, but in the end, it's turned out to be just another quadratic that needed to be factored. And whatever factoring technique you like, feel free to use. I know I've seen other people do like crisscross method or something, or British method, or whatever technique you want. Personally, this is the way I learned it, so that's the way I do it. All right, so hopefully that helps. If you have any other questions, please let me know, and I will talk to you guys later. Bye.